Hi, this is Dan, and this is the Napkin Academy. The lesson we're going to work on now is 6x6 picture type number 2, which we already know is called a chart. And as we remember that a chart is the kind of picture that we want to draw in our 6x6 when we want to show how much. We draw a chart, a visual representation of number. Now, as we might recall from looking at our simple pictures, first thing that we saw when we were looking at this picture, the first thing that our mind's eye saw, our visual processing system, is we picked up the objects. Well, at the same time, we're doing something else. We're also counting. We're not just noticing that there are objects, we're also noticing how many of them are there. So this is what we're going to call the how much pathway into our vision system. And this is the part that's looking out at this picture and saying, oh, look, there are 4 of those. And oh, look, there are 1, 2, 3, 4, 5 of those kinds of things. And look, there are 1, 2, 3, 4 of those things up high in the sky. There is only 1 of those as far as I can tell. There's only 1 of those. There are 2 of those. Point being, of course, this is the part of our visual pathway that is counting the numbers. Now, the reason that this is important is it turns out that we as people are actually pretty bad at counting. In fact, if we were to look at these little piles, let's call them little piles of, let's make it exciting, let's say that they're money. Let's say that these are piles of coins. How many of these piles can you look at instantly and know how many coins are in each pile? Most people can look at this one and say, we don't have to count. We know how many that is. Most of us can look at that one, know how many it is. And most of us cannot look at that number and know how many it is. In fact, it turns out that for most of us smiling people, the biggest number that we can look at and know how many it is without counting is 5. 5 is about as good as we can go. So it turns out that we as humans, when we count, we really count something like this. 1, 2, 3, 4, 5, a few, lots, and zillions. And that's the way we actually count in the world, which makes it kind of absurd the way that we handle big numbers, especially in the press or even in school or certainly in finance, because we throw out these massive numbers, $700 billion bailout. Okay, I have no idea how big that is. What's the U.S. debt? $15 trillion in debt. Well, okay, I have no idea how big that is. Which one's bigger than the other one? I think this one's bigger, but I really don't know by how much. Oh, and here comes the lottery. And guess how much someone won in the lottery last week? They won $6 million. Wow, $6 million. Boy, are we all excited about that. We are just yelling, and we have no idea how much money $6 million is. We have no ability to really compare it to that 15 trillion or back to that 700 billion. You know, for most of us, for me, I'm going to be extremely personal with you right now. I am just incredibly happy if I get a $299 refund on my taxes. That just makes me about the most ecstatic that I could ever be. That's a number that seems really big when it finally comes in. The point I want to make, of course, is that we're lousy at looking at these big numbers. So let's do our run through on the specifics of picture type 6x6 number 2. The name of this picture is the chart. An example. Watch how I draw this, because most charts are going to start in a similar way. We're going to talk about this in a moment. I give a coordinate system. Yes, that famous old coordinate system again. Most charts are going to have a coordinate system that's overt. And in this particular case, I'm going to say price. Price in charts is often on the vertical scale. And we're going to just demarcate out some price. It doesn't really matter. We're going to say 1, 2, 3, and 4. Whatever that unit is, $4. And what we're going to put down here is we're going to put items. And in this case, let's call them countries. And let's compare USA, Europe, and say China. And let's map out what is the price of tea. So in the United States, the price of tea is $2 for tea. In Europe, the price of tea is $3.50. And in China, the price of tea is about 75 cents. So there, we've created a chart, and we can now give it a name. We can say the price of tea in China. And without having to remember anything or count in any detailed way, we can look at that chart and we can immediately see where is tea the most expensive right now. It's expensive in Europe. Where is tea the second least expensive? It's in the United States. And where is tea the least expensive right now? It's in China. And how do we know that? Because we are able to look at the relative size of those numbers. We're looking at a picture of number, and all of those sudden, by being able to compare them, those numbers become very clear. So what does a chart show? Well, it shows, of course, how much, and it shows how many. What is the coordinate system for a chart? Typically, the coordinate system for a chart is going to look like the one we drew over here. Typically, not always, but a chart is going to have some number as one of the axes. So we're going to come up with a potentially multi-dimensional system, but all we really need to do to be able to start drawing it, to create the coordinate system for a chart, is just to map out any single numeric item. That could be price, that could be amount, it should just be quantity, could be number, but all we need to do to create a coordinate system is say, okay, I'm going to count something. And now we can start to map in our data. So what is the relationship of objects within a chart? Well, the relationship is always relative quantity and relative size. Those are the relationships. And what is the starting point for our chart? Is we just pick our coordinate system, we test something, and we just pick a coordinate. So the first thing we do is we pick any coordinate and we say, let's give it a number, and let's start from there. We pick a coordinate system that we're going to start mapping in. That's our starting point, and then eventually the other coordinates will come into place as well. So let's look at some examples of charts, lots of different kinds of examples. In fact, it's interesting to note that if we think about it, charts probably represent about 90% of all business visuals. And there's a chart showing exactly that. Now the reason is because we know, as being good business people and good thinkers and trying to explain ourselves well, we know that it's important to use visuals, but the only visuals we really tend to focus on very much in business are those that show how much. Now, it's great that we use visuals to show how much, because we've seen how lame we are at actually looking at numbers. Whoa, what? So if we use charts, we can get it really easily and quickly. But the thing that we're missing, of course, is if we focus only on charts, which represent, as I say, 90+% of all business pictures, we're missing all of those other kinds of pictures that we saw in the 6x6. We're missing our who's and our where's and our when's and all those others. So charts are great. There's lots of different types. And let's explore some, keeping in mind that there are also a lot of other types of pictures that we want to draw. Well, we've already seen with our price of tea in China, the most standard kind of a chart, a bar chart. So there's a sample of a chart where we're simply showing relative number on a horizontal and a vertical axis. You know, if we want to be clever, of course, we can lay our bar chart on the side. This is often used when we're measuring time, when we're actually measuring time. This tends to be when we're measuring money. And there's another entirely different kind of a chart. We've seen one already, the famous pie chart, sometimes thought of as the infamous pie chart. You know, a lot of people in data visualization just hate pie charts. I don't have a big problem with pie charts. I mean, if anybody's ever been, imagine if you've ever been to a birthday party for, you know, a bunch of little 8-year-olds, and you watch them, and this is the pizza, they have no problem figuring out which slice of the pizza is biggest. No problem whatsoever. A lot of people who don't like pie charts, the reason we don't like them is they say that it's difficult to judge the relative sizes of one slice to another. There's some truth to that. The beauty of a pie chart, of course, is that if we want to show something's proportion to the whole, if we're measuring everything against 100%, a pie chart is a really great way to show how things divide up within the context of the whole. That is not true when we're using a bar chart. A bar chart is not so good for showing things in comparison to the whole. It's much better in showing things in comparison to each other. The beauty of the pie chart, the often lamented pie chart, is that it's great for showing the relative amounts to each other and to the whole. So go ahead and use pie charts. The reason that people don't like pie charts is because we have this tendency to think that they're not sexy enough the way they look like here. So we have a tendency to make them into this kind of a 3D object, something like this. And now the fact is, when we slice them up, it does become almost impossible to tell which side is actually bigger than which other side because of this 3D business. So if you're going to use a pie chart, no 3D. Just keep it straight up and down. Good old 2D, a perfectly round circle, divide that thing up, and we're all going to understand which slice is the biggest. And you know what? One other note, if we can't tell which slice is the biggest, then guess what? It doesn't matter. That's not the point. The point is then, if we can't tell, if the two sides are so close that they almost look exactly equal and we can't tell the difference, then the point the chart's trying to make is that the two sides are effectively equal. And that's another interesting takeaway right there. A couple of other examples of charts that we can do. Bubble charts getting a lot of play lately. The idea behind bubble charts, these kind of look like those balls that we were drawing back in portraits. What they really are is they're a way to show relative numbers. So let's say this is about 20, this is 15. I'm going to say that this is about 10, this is probably about 3, and this is probably about 1. So what it is it's possible to show the relative size of numbers very quickly so that we don't have to mentally do any arithmetic and say, well, 20 is how much bigger than 15 or how much bigger than 10, because we can just see it. So those are called bubble charts. Very useful when we're comparing multiple dimensions, and in fact we're going to see bubble charts a lot when we start to make plots. So there's a little preview of coming attraction. We're going to see a lot of bubble charts. And you know, another type of chart, something you see if you've ever been asked to do any sort of school fundraising or you know, try to measure something for the money that you're raising for the business lotto pool or something like that. You know, we use a thermometer, and the idea is our objective is here, and what we can do on our little visual chart is say, well, we've reached this point, and now we've reached this point, and now we've reached this point. And again, what are we showing with even this kind of thermometer chart? We're showing the same thing. We're showing a visual representation of number, and that is really all that we're going to show. A couple more thoughts about charts. When do we use them? When do we use charts? Well, whenever we want to show numbers, whenever we want to show numbers. So that would be whenever we want to measure pretty much anything, but we certainly want to measure absolute quantity. When we want to measure absolute quantity, we make ourselves a chart and we give it fixed numbers and we say this is 1,000,000 and this is 0 and that's how many there are and that's how many there are and that's how many there are. So when we want to measure absolute quantity, and a chart is also great when we want to measure relative quantity. And in fact, the same chart shows the same thing. It's interesting because here we've got absolute numbers. Let's say this was 0.85. This was 0.5, and this was 0.85. Well, it's interesting because if we were to put them in the table would look something like this: 0.85, 0.50, and 0.85. Now, if we were to look at that, the fact is the size difference between them does not become clear. That's why a chart's nice, because it makes the size difference visual. It gives us absolute number, and it also gives us relative numbers. So we can glance at it quickly and say, well, I know that that one and that one are bigger than that one. This leads us, of course, to any time we want to do any kind of financial analysis, anytime we want to look at the money, we're going to end up drawing some charts, which of course is why charts are so popular. Why, charts, big thumbs up for charts in those big PowerPoint presentations that we often see that contain so much information, and when they have a picture, they do have a chart, because the thing that we want to talk about is the financial analysis. What's the quantitative view? We draw ourselves a chart. And kind of the last time we want to use a chart is when we simply want to compare amounts. Compare amounts of anything. Let's say that I want to compare the number of apples I have to the number of oranges I have. When I want to compare amounts, I could write a number, and that's interesting. That number starts to become less useful when the numbers start to get closer together or the numbers start to get really big, or they start to become very specific. So in that particular case, what I'd want to do is just go ahead and make a comparison and say, apples, well, I've got this many. And oranges, I've got this many. Now again, these are not really countable numbers, but I can very quickly look at these two numbers, these two charts, these two visual representations of number, and see the difference very quickly. Okay, so that's all we wanted to know about charts. To summarize charts, for our last takeaway from the type of pictures that we draw when we want to show number and we want to show how much, let's take a moment and look at let's make a bar chart. So we've drawn our coordinate system, and what this is going to be is item. That's the way we start every chart, and now I'm going to make another one, which is amount of time. Amount, in this case, of time. And what I want to talk about are the 4 steps of the visual thinking process. Look, see, imagine, and show. And in my estimation, we do not spend the same amount of time on each of these 4 steps, either in training or in practice. In fact, I would say that in terms of talking about the steps, show is going to be the least. We're not going to spend a tremendous amount of time in these lessons talking about show. The one we're going to talk the most about is the one where we are right now, which is seeing. Seeing, to me, is where the greatest breakthroughs in becoming a good visual problem solver are. So we're going to spend a fair amount of time on seeing. Looking, we're going to spend a little bit of time. And imagining, we're going to spend almost as much time as we did on seeing, but there will be a few lessons fewer. There's a lot that we want to focus on when we talk about imagining, but nothing compares to the importance of understanding how do we see better.